Okay, so this is a review of one of the foldables that we made in class, talking about the states of matter. We're going to talk about the states of matter with water. Okay, so liquid water, solid water, which is ice, and then water vapor, which is found in the air as humidity. So what we need to remember is that when we go from a solid to a liquid to a gas, the particles or molecules of the water changes. The particles actually are tightly packed in a solid. In a liquid, they're a little bit more loosely packed, and in a gas, they're very scattered, scattered so much so that we don't even see them. And what we also need to remember is that as we go from a solid to a liquid to a gas, we must increase the temperature. So as temperature goes up, we get a phase change from solids to liquids to gas. Similarly, if we go from a gas to a liquid to a solid, we decrease the temperature. So as temperature goes down, we go from gas to liquid to solid. The next thing that you need to remember is for water, I'm going to use degrees Celsius because I think it's important that you use the scientifically accepted temperature scale. Water will change from a solid to a liquid. From a liquid to a solid at its melting point, and from a liquid to a gas at its boiling point. The melting point is 0 degrees Celsius, to go from a liquid to a solid, it's 0 degrees Celsius, and go from a liquid to a gas, the boiling point is 100 degrees Celsius. Okay, so that's melting point, boiling point. So solid will melt at 0, liquid will vaporize at 100. The next thing we need to talk about is, does that matter have a defined shape and a defined volume? Now, what do we mean by that? I'm just going to put defined shape, and defined volume. Def volume. And what we need to know is that, does the substance, the solid, the liquid, and the gas, does it maintain its shape when placed in another location? So, for example, if I take a solid like this pen and I move it or put it in a different container, is it going to have the same shape? Yes, it will maintain its shape, and that's a property of solids. So I'm just going to put a check there that it does, yes, it does have a defined shape. Now, will it have the same volume? Will it take up the same amount of space if I put it in a different container? Yes, absolutely. That's another property of solids. They maintain their shape and their volume. Now, a liquid. If I take a liquid and take it from a water bottle and I place it into a bathtub, does it maintain the shape that it was in the water bottle? And we know, no, it doesn't. So liquid does not have a defined shape because it takes on the shape of the container that you put it in. The volume, however, of the liquid will remain the same. So if you take 100 milliliters of water, pour it from a beaker into a bathtub, it's still 100 milliliters of water. So it maintains its volume. Now, a gas, you need to understand that when a gas goes from one container to another, it does not maintain its shape. So imagine you have a balloon and you let the air out of the balloon. It doesn't stay in that balloon shape when the air comes out of the balloon. So it does not maintain its shape. And volume, the balloon has a certain volume, But when you let the air out of the balloon, the air spreads out, and so the volume will increase. So the volume is one amount inside the balloon, and it'll be another amount when it comes out of the balloon. So it does not have a defined volume. And so when you're doing questions like this on exams and tests, what you should really do is quickly draw this little chart to help you answer the questions, because sometimes questions require you to think about what two things have in common. Like, for example, it says, it might say, what state of matter does not have a defined shape, in which case you would know that it was a gas or a liquid. What state of matter does have a defined shape, in which case you would know that it is a solid.